ये नहीं चालू केलं का? चालू करो. आलं? आलं? चलो. Yes. So now we shall see the next chapter, that is in conics ellipse. As usual, definition. It is a locus of points, right? It is a locus of points which moves in such a way that a point whose distance he moves on the curve such that the ratio of that point from a fixed point called focus to means upon its distance from a fixed line called directrix bears a constant ratio eccentricity E. It is a locus point. It moves such that the point is such that its distance from a fixed point called focus SP to its distance, that distance of that from a fixed line called directrix bears a constant ratio SP, and that is a PM distance bears a constant ratio E, where E less than 1 for the ellipse. So it is a locus of points which moves in such a way that its distance from a fixed point focus S to its distance from a fixed line directrix D bears a constant ratio called eccentricity, where E less than 1. Correct? That a collection of points is called ellipse. Every point must be such that distance of that point from a fixed point focus S to its distance from the fixed line directrix D must be bears a same, a constant, a ratio, eccentricity E, such that E less than 1. Okay? For example, see that. Find the equation of ellipse whose focus is minus 1, 1 and directrix is x minus y plus 3 is equal to 0. Let P x y be a point belongs to ellipse. Any point. Focus is s minus 1, 1. Directrix is x minus y plus 3 equal to. What is the definition? What is the definition of that? The distance of that point from a fixed point focus S, SP. And from point P, draw perpendicular on the directrix, that is a PM. So distance of that point P from the directrix PM. So SP upon PM is equal to E, where E less than 1, it is called focus directrix property. Distance of that point from the focus to its distance from the fixed line is equal to E. So SP is equal to E is given. What is E is given there? The example where eccentricity is equal to 1 by 2. SP is equal to 1 by 2 PM. So SP square, in order to use the distance formula, we don't require the root. SP square is equal to 1 by 4 PM square. Continue for that. Yes, that is sorry, x plus 1 bracket square plus y minus 1 bracket square, because 1 minus minus 1 1 is a point. 1 by 4 square is 1 by 4 x minus y plus 3 upon. So formula is that ax1 plus by1 plus c upon root of a square plus b square, perpendicular distance formula. So line is x minus y plus 3. Point is pxy, no problem. X minus y plus 3 upon root of coefficient of x 1 square, coefficient of y minus 1 square is 1 again. So therefore x square plus 2x plus 1 square plus y square minus 2y plus 1 is equal to 1 by 4 x square plus y square plus 9 minus 2xy minus 6xy a square plus b square plus c square, all plus product of these two twice, product of these two twice, and product of first and third. Product of these two twice minus 2xy, product of these two twice minus 6y, product of these two twice plus 6x upon root 2 square is 2, 4 2s are 8, multiply there by 8 and then simplify. It's easy. Actually, I have shown there. So simplification. Final equation comes 7x square plus 2xy plus 7y square plus 10x minus 10y plus 7 is equal to 0. I collected the term. Not necessary that equation must be always in the form of x square upon a square plus y square upon b square equal to 1. It may be in the form. Obviously, its discriminant delta b square. That is, what is the discriminant delta? H square minus AB, right? That is delta AHG, HBF, GFC determinant is not equal to 0, and H square minus AB must be greater than 0, right? Correct? So this is as the equation. No need to, that means no need to think for you, because it is given. That is a directrix and the point. From there, just draw the perpendicular to get the distance formula. So SP upon PM is equal to simplify. This is specifically I given that equation must not be in the form always x square upon a square plus y square upon b square equal. It may be transfer again, collecting the x square, x, y square, y, and it's continuing like this. Okay. Now next, that is okay. Just wait. So this is equation. Okay. This is standard equation of ellipse. I show x square upon a square plus y square upon b square equal to 1. A greater than b. A always greater than b. Then it is like this standard parabola. Standard ellipse like this, where b square is always given by a square into bracket 1 minus e square. It's a standard, remember that. Curve is symmetric. Curve is symmetrical about both axes, x-axis and y-axis. X-axis and y-axis are axis of symmetry. They are the axis of symmetry. Center, the point which bisect each chord of it passing through it. If it is one of the chord passing through O, so at point O it is a bisected. Draw another chord here from through O. O bisect it. So therefore O is called 0, 0, center of that ellipse. Curve is symmetric about both axes. It has two foci, S and S dash, and two directrix D and D dash, two directrix there. Equation where S has a coordinate A is 0 and S dash minus A is 0, and equation of directrix x equal to A upon E and x equal to minus A upon E, a standard one there. Yes, that is. Curve intersects x-axis and y-axis in point capital A. That capital A has a coordinate A0 and A dash minus A0. B, 0B and 0 minus B. These are the vertices. It has four vertices. AA dash, this length AA dash is called major axis, and BB dash is called minor axis. Length of major axis AA dash is equal to 2A, and length of minor axis BB dash equal to 2B, right? Major axis and minor. I explain here a standard form of ellipse there. Okay. Now distance between foci, S is A0, S dash minus A0. So distance between foci 2A. Distance between directrix 2A upon E. Equation of directrix A upon E. So distance between directrix. Remember that these are useful while finding equation of ellipse. They are given just some conditions. If a distance between directrix is given some say 5, 7, it's whatever it may be. From that you can calculate A, E with the other relation. Latus rectum, chord of ellipse passing through focus perpendicular to axis is called latus rectum, LSL dash, and the length of latus rectum is to be square upon A, and the coordinates of end points of latus rectum L and L dash. L, keep the constant coordinate of x of the S focus AE comma, make the half of that AE comma B square upon A, and L dash AE comma minus B square upon A. So this is end point. I shall show you that. Listen here, that is right here. Okay, I shall show you the latus rectum here. That is LSL dash. Here also one more latus rectum, that is LSL dash. Here also LSL dash. So we get that two latus rectum, that is called two latera recta. That is a plural of latus rectum, latera recta. All right, LSL dash. It is a focal chord perpendicular to axis, perpendicular to axis. Right. Next. That is, so we have up to this. Now focal distances of any point P, x1, y1, b, any point. So you observe here, observe the figure there. So there are two focal distance. If P is any point on that, SP and S dash P are the two focal distances for every point on the ellipse. And the value of this becomes, that is, SP focal SP is equal to A minus EX1 and S dash P is equal to A plus EX1. E, remember that E less than 1, X1, Y1 is a point on the SP is equal to A minus EX1 and S dash P is equal to A plus EX1. What will happen with considering these two distances? Sum of focal distances A minus EX1 plus A plus EX1. EX1 cancel, that is A minus. So it becomes only 2A with the length of major axis. So we have the property of sum of the focal distances of any point, sum of the focal distances of any point on the ellipse is equal to a length of a major axis is equal to 2A. Correct? Next. So these are the properties that we are going to see there. Okay. Example. What is the equation of ellipse? With foci plus or minus 2, 0 and eccentricity 1 by 2. Foci plus or minus A0 is equal plus or minus 2, 0. A is equal to, so A into given 1 by 2 is equal to, so A is equal to 4. Once you get A, I want a B only. The very important relation. So B square is equal to, for the standard, B square is equal to A square into bracket 1 minus E square. So simplify. B square is equal to A square minus A square is square. It's a focus. Focus is given, that's equal to 2. 2 square. So B square is equal to 16 minus 4. So B square is equal to 12. I have the value of A and B. So required equation of ellipse x square upon A square plus y square upon B square equal to 1. Very easy. X square upon 16 plus y square upon 12 is equal to 1. So this is the direct value B square. So with the help of this, we can obtain the equation, right? Some example. Please. If Pxy, F1 also denote for the focus, F1, F2, two foci. It is the equation of ellipse. Find PF1 and PF2. Find eccentricity, length of latus rectum, and coordinates of endpoints of latus rectum. Okay. So first of all, x square upon dividing by 400 there, x square upon 25 plus y square upon 16 equal to 1. Here dividing by 400. Since b square is equal to a square into bracket 1 minus e square, so 16 is equal to 25 into bracket 1 minus e square. So 16 upon 25 equal to 1 minus e square. So e square is equal to 1 minus 16 upon 25. So e square is equal to 9 upon 25. E is equal to 3 upon 5. Only positive, only positive. It's a ratio, right? Length of latus rectum is equal to b square upon a. That is eccentricity that we obtain here. Length of latus rectum there. So 2b square, 2 into, what is the b square here? 16 upon 5, 32 upon 5 or 6.4 units. Coordinates of endpoints of latus rectum L. First write AE, and for the L dash also write AE, that is, sorry, Right. So AE B square upon E and L dash AE minus B square upon E. Make the half of that. So 3 comma half 16 by 5 L dash 3 comma minus 16 by 5. PF1 plus PF2. What is that? Sum of the focal distances of point P. Array, what we have? Just now we had the property here. Sum of the focal distances of any point on the ellipse is equal to length of major axis is equal to 2a is equal to 2 into 5 is equal to 10 units. Correct? For this, that I have taken the example immediately on that particular part. Next, that is continue. Let P be a variable point on the ellipse x square upon a square plus y square upon b square equal to 1 with foci S and S dash. If A is area of triangle P S S dash, then find the maximum value of A. Which type of that? Listen here. So this is ellipse, right? Point P moves. This is a point. This is S. This is S dash. Right. This is a triangle. Its area is given there. P point, and I am taking the parametric form. I shall give you the table there for the parametric form. P point, parametric form. A cos theta, B sin theta. Focus S, A E 0, S dash minus A 0. As you know that x1, y1, x2, y2 and x3, y3 are the vertices of triangle. Then the area of triangle is given by half determinant x1, y1, 1, x2, y2, 1, x3, y3, 1. So area of PSS dash become A cos theta B sin theta 1. A 0 1 minus A 0 1. Simplify it. So this is 0. No problem. 1 half 2 AEB sin theta. 1 half 2 AEB sin theta. A cos theta into bracket 0. No need. Minus B sin theta into bracket AE minus of minus plus AE become 2AE. So 2AE and B sin theta. So 2AE sin theta for the one again it's 0. So 1 half into again A cos theta into 0. No need of writing. Minus B sin theta into bracket AE minus of minus plus AE. So 2AEB sin theta minus becomes a plus because it's area. So that's equal to AEB constant comes outside. 2 to cancel, only sin theta. It is a maximum when sin theta is maximum. What is the maximum value of sin theta? Is a 1. So A is a maximum when mod sin theta is equal to 1. So maximum area becomes AEB because maximum value of sin theta is 1. So this is a maximum area of triangle formed by the point on the curve and S and S dash. Correct? Just I'm taking the example immediately. Okay. Now equation olive in another form. This is another form. Opposite exactly capsule form. A vertical capsule form. Right. Here. Remember that. Here what happens? Now AA dash becomes smaller than BB dash. So remember AA dash becomes a minor axis in that case. BB dash becomes a major axis. Focus S become lie along the y-axis 0 BE in the previous thing AE 0 BE and S dash 0 minus B. What is the equation of directrix in the previous? X is equal to A upon E. Here Y is equal to B upon E, and here also that is for this Y is equal to B upon E, and here also Y is equal to minus B upon E. So these are the two directrix. Curve is symmetric about both axes. 4 vertices. Same here. And here, instead of B square, we have A square is equal to B square into bracket 1 minus E square for the vertical. A capsule form, ellipse, vertical, opposite form. So distance between foci, there was a 2AE, here become 2BE. Distance between directrix, there is 2A upon B. So 2B upon A, 2A upon E, 2B upon E. Length of latus rectum, Here it was 2b square upon a. Here comes 2a square upon b. And coordinates of endpoints of latus rectum L. Remember that. No change of x coordinate of focus BE. Only make the half of that a square upon b comma b. A minus a square upon b comma b. These are the two endpoints of the latus rectum. So I shown there if the parabola. In that case, what happens? How to recognize x square upon a square plus y square upon b square is this type. In that case, a less than 1, a less than b, a is smaller than b square. Immediately, a square is less than b square. Immediately say that that is a vertical or a capsule form ellipse, and we can continue for that. Okay. Now, for this, we shall make the table for that. Observe the table carefully. X square upon a square plus y square upon b square equal to 1. A greater than B, space, that is as usual standard. A less than B, capsule form, right? And I given center 0, 0, 0, 0 center. Vertices A 0, A dash minus A 0, B 0 B, B dash 0 minus. Same, no change for their vertices. Length of major axis 2A, but length of major axis 2B for the vertical. Length of minor axis 2b, length of minor axis 2a, exactly opposite. Equation of directrix x equal to plus or minus a upon e. Here y is equal to plus or minus b upon e. The table, remember this table carefully. Relation between a, e and b. Here comes in the standard b square is equal to a square into bracket 1 minus e square. But here come a square is equal to b square into bracket 1 minus e square. No change. A length of latus rectum to b square upon a. Here come to a square upon b. So coordinate of endpoints of latus rectum L. A comma b square upon a comma minus b square upon a. And here comes a square upon b, b minus a square b comma b, length of latus rectum. So these are the 2 points there. For another latus rectum, there are 2 latus rectum there. Yes, see that previously. If you want, you can see there. See, 2 latus rectum are there. The previous also we have shown that. So that is a length of latus rectum. Okay. Now listen there. So this is table 2, basic fundamentals again. X square upon a square plus y square upon b square equal to 1. A greater than b. Here a less than b. Right? Capsule form. Parametric equation. X equal to a cos theta. Y is equal to b sin theta. Here x equal to a cos theta. Y is equal to b sin theta. Provided 0 lying between 0. Theta lies between 0 and 2 pi. Not equal to 2 pi. Right? 0 can take the value. Right? So that is focal radii. SP is equal to a minus ex1 and h dash p is equal to a plus ex1. A minus e into x coordinate of the point and h dash p is equal to a plus e into x coordinate of point. Right? And here SP become opposite exactly. B minus ey1 and h dash p is equal to b plus ey1. There. A SP is equal to a minus ex1, a plus ex1. Here come b minus ey1 and b plus ey1. Sum of focal radii of SP plus S dash P is equal to 2A. Here 2B, not A, 2B, because 2B becomes a major axis. 2B becomes a major axis and 2A here becomes a major axis. Distance between foci 2A. Distance between foci 2BE, because 0B and 0 minus B. Right? And here distance between directrix 2A upon E, and this is there 2B upon E, 2A upon E, 2B upon E. And tangent at the vertex x equal to minus A, x equal to A, y is equal to B, and y is equal to minus B. Array at the point A and B, these are the tangents to be considered, right? So the at point x equal to x, first coordinate capital A is A0. So at this point x equal to A, minus A0, x equal to minus a. For the elliptical, here y is equal to b, there comes y is equal to upper, y is equal to b, y is equal to minus b. These are the tangent at the vertex. So table I have shown for to compare with them. Again examples. Find focus of an equation of directrix. Focus and equation of directrix of this. Also eccentricity. Comparing x square upon 16 plus y square upon 25 equal to 1. A square equal to 16. B square equal to 25. A less than B. Capsule form. All is invertible. They're right. So therefore, it is second form. So a square is equal to not b square. A square is equal to b square into bracket 1 minus e square. So a square is equal to b square minus b square e square. So b square e square transfer on this side is equal to b square minus a square. So b square e square is equal to 25 minus 16. It is a square, it is b square. So b square is square equal to 9. BE is equal to plus or minus 3. The coordinate of foci 0 plus or minus 3. Calculation I'm doing with you actually, right? Yes. Now what you required? Again it is a vertical capsule form. So a square is equal to b square into bracket 1 minus e square. So 16 is equal to b square is 25 into bracket 1 minus e square. So 16 upon 25 is equal to 1 minus e square. Transfer e square on this side. E square is equal to 1 minus 16 upon 25. 25 ones are minus 16. 9 upon 25 is equal to e square. So e is equal to 3 by 4. Also find eccentricity 3 by 4. Observe 3 by 4. It is a less than 1. It must be eccentricity of the ellipse. Then equation of directrix. It is not a standard one. Remember that. Directrix x equal to no, y is equal to. Y is equal to b plus or minus b upon e. So y is equal to plus or minus 5 upon e means 3 by 5. So y is equal to plus or minus 25 upon 3. I have shown this example. It's a capsule form, but we can get it here. Right? Next, that is, what is a curve represented by x equal to this one and y is equal to this one? Some example. Listen, what is the value of this one? X upon 3 is equal to cos t plus sin t. Y upon 4 is equal to cos t minus sin t. Wherever cos t plus sin t, cos t minus sin t is given to you, if you want to find the locus, eliminate the t. How? Just square and add. Just square and add. Only in the case of cos and sin, plus and minus is given. Squaring and adding, x square upon 9 plus y square upon 16 is equal to square of this cos square t plus 2 sin t cos t plus sin square t plus cos square t minus 2 sin t cos t plus sin square t. If 2 sin t cos t is cancelled, cos square t plus sin square t becomes a 1. That cos square t plus sin square t becomes a 1. So x square upon 9 plus y square upon 16 equal to 1 plus 1. So it becomes a 2, which represents an ellipse. Because what type of ellipse is that? Here a square is less than b square. It is a capsule form, a vertical form, a opposite form, and not a standard form of ellipse. Correct? But it is an ellipse. Okay? So curve represents ellipse there. Right? So find the foci of the ellipse 25x plus 1 bracket square plus 9y plus 2 bracket square equal to 225.